Hi friends, today we are going to see the concept that is common mode rejection ratio. So this is the parameter which is used to tell whether the op amp is giving better performance or not. So this common mode rejection ratio will differ for different ICs of operational amplifier. So here we know that this operational amplifier internal block consists of a differential amplifier circuits, or we can say that the cascaded of differential amplifier configuration blocks. So we know that in the differential amplifier, it operates in two modes. One mode is a differential mode and second mode is a common mode. So finally, this output voltage V0 is nothing but the sum of the differential mode output voltage and the common mode output voltage. Let us see in brief what is the output voltage of differential mode op amp and the common mode op amp. Okay, so in the differential mode, the two input signals, that is V1 and V2, will be differ, and we are considering this op amp is operating in open loop configuration. Okay, so these two input signals V1 and V2 will be differ, so we can write the output voltage V0 in differential mode is nothing but gain multiplied by difference of two input signals, that is V0 is the gain of differential mode gain, that is AD into VD. Okay, so here the VD is nothing but the difference of two input signals. So we know that subtraction is nothing but higher signal minus lower signal. So VD is nothing but V2 minus V1. So this is the output voltage of differential amplifier or operational amplifier in differential mode. Okay, now see what is the output voltage of op amp in common mode configuration. So in the common mode, these two signals, that is V1 and V2, will be same. We can say that some environmental signals like noise signals or temperature signals are applied to this operational amplifier. We can call it as a common mode signal, that is a VC. Okay, so when VC is applied, this V0 value will be equal to V0 is AC into VC, where AC is the common mode voltage gain of operational amplifier or differential amplifier. In that case, this VC value we can write as average of two input signals. So what is the average of two input signals? It is V1 plus V2 by 2. Ideally, here if a common mode signal is applied to an operational amplifier or a differential amplifier, this output voltage will be always zero. Why? Because it has to reject the noise signals or environmental signals. Okay, so how much rejection this operational amplifier is giving, or is it able to reject these environmental signals? This parameter is defined by the common mode rejection ratio. So finally, the output voltage of an operational amplifier or a differential amplifier, we can say that this output voltage V0 is the V0 due to differential mode plus V0 due to common mode. So the equation finally it is V0 is VD into AD plus VC into AC. So this is the final expression of an operational amplifier or a differential amplifier output voltage. Okay, now we are going to see what is the exact definition of common mode rejection ratio and how this output voltage V0 will be expressed in terms of common mode rejection ratio. From this we can say that the differential amplifier or operational amplifier has to amplify the difference of input signals and has to greatly reject the common mode signals that are applied at inputs of differential amplifier. Okay, so in order to reject the common mode signals, we are defining this with the parameter that is the common mode rejection ratio. So the common mode rejection ratio is nothing but the ability of a differential amplifier to reject a common mode signal that is expressed in CMRR, that is common mode rejection ratio. Mathematically, this CMRR is expressed or is defined as the ratio of differential mode gain to the common mode voltage gain. Okay, so mathematically it is the ratio of differential voltage gain, that is AD, to the common mode voltage gain AC. Okay, so it is expressed in terms of gain, and it is indicated by the symbol that is rho. So CMRR is rho is, it is a positive value, so we have kept a magnitude, it is AD by AC. Now this CMRR can be represented in terms of dB. So we know that the gain in dB is 20 log of AD by AC. So this is how we represent the CMRR in dB. So if you consider the ideal case of op amp, so for the ideal case, it has to greatly reject the common mode signals. So we can say that this AC value will be 0. Okay. So in that case, what is the value of CMRR? It is 1 by 0, which is infinite. So we can say that if for the ideal case of op amp, the CMRR value will be infinite. If you consider for the practical op amp or practical differential amplifier, this AD will be large and AC will be small. So in order to give better performance, the CMRR value should be high. If the CMRR value should be high, the denominator part should be low. So here the AC value should be small in order to get high value of CMRR. Now we are going to see how to express the output voltage of differential amplifier in terms of CMRR. So we know that the output voltage of differential amplifier V0 is AdVd plus AcVc. Now from this expression, common AdVd. If you common AdVd, then the expression is 1 plus Vc into AC by AdVd. Okay, we know that the CMRR mathematical expression is rho is AD by AC. Okay, so we can say here this AD by AC is nothing but definition of rho. So we can write AC by AD as 1 by rho. So finally the output voltage V0 is AdVd into 1 plus 1 by rho into Vc by Vd. Okay, so for the high value of CMRR, we can say that this rho value will be high and 1 by rho value will be less, which is always less than 1. So we can easily neglect this term, that is 1 by rho Vc into Vd. Finally, the output voltage V0 we can write as AD into Vd for the higher values of CMRR. So this is how we have expressed the output voltage V0 in terms of CMRR value. Thank you.